Okay, cool. So this portion of the project was using text modeling to understand the reviews and categorize them based on the way that the rating came out. Ratings are quite popular for text classification purposes because of that exact reason. You can basically learn how to predict whether reviews will be high or low based on the text and discussion that goes on. And then theoretically, as a business use case, you could change the business to try to earn certain types of reviews. And that's basically the use case that we were pursuing here. My name is Jacob Silver, and my group mates were Greg Malloy and Justin Williams, and this is a continuation of the same Yelp data that we were using in the other parts of the project. So basically, we run some imports for data analysis and for machine learning and for visualization, pulling in our Yelp review data from a pickle file, simplifying the column names in that data and reducing the data frame to only the columns that we care about. The rating, which serves as the Y variable, and the text, which would be the array of our X variables. So breaking out the reviews that occur in the data, we can see that they're not evenly distributed at all. 5-star reviews are by far the most common, make up the plurality, actually even the majority of reviews, which is good for those businesses, but not as great for the purposes of text classification, both in terms of the skew of the data and also really just the lower sample sizes for some of the lower reviews. So in some of our testing, we found that it was difficult to get really accurate ratings in the test data for these lower reviews. So what we ultimately decided was actually to reduce the data into a binary of 5-star reviews versus non-5-star reviews. 5-star reviews being represented by ones and zeros representing 1 through 4-star reviews. We recognize that this is a trade-off, particularly because there's quite a span between 1-star reviews and 4-star reviews. But we felt that there was still enough of a distinction between a 5-star review, which constitutes a sort of a perfect or ideal review, versus any review in which a star has been docked. We felt that that was a strong enough distinction to say a perfect versus an imperfect review to still create useful data for a classification purpose. And I think that's what we found overall. And certainly the distribution here is much better and the sample size is much better for the purpose of text classification. Just preserving a copy of the original data frame here because we're going to manipulate it and we want to be able to re-access the original text at a later time in the notebook. So before we run the actual vectorization and build the classifier, we're actually going to stem the text, which basically just means reducing it to its each word to its sort of component parts or its sort of core part, so that words like amazing and amazed are actually considered the same. We felt that this was especially important in relatively small sample data where you want to maybe reduce the number of features a little bit and make sure that that words that are used in the same context are considered, even if they are used with a slightly different syntax or mode, different suffix, etc. Less important, I think, for maybe bigger data, but for here we felt it was very useful. So then we're splitting our data into training and testing data using the train test split function in scikit-learn, and initializing our vectorizer, which we decided to use a TF-IDF vectorizer, which contrasts with a count vectorizer. So instead of just counting up the number of occurrences for a particular feature in a particular review, it actually scores each feature for that review based on the relative frequency of that term. And so terms that are relatively unique for a review might score more highly or will score more highly than words that occur more commonly. And this is a way to kind of account for words that are maybe going to be, should be treated as less predictive because they're actually used in many different reviews. Like, for example, I think a word like food would score low here because it's not very useful from a prediction standpoint. So we fit that vectorizer to our data, transform our X data on both the training and testing sets into a 2-dimensional array. And just for the purposes of visualization, convert that into a data frame, not actually used in the analysis, but just a visual way to understand what's actually happening here, where the rows are the vectorized pieces of text for each review, and the columns are the features that occur throughout the corpus. So now we can instantiate our classifier, which we're using a multinomial naive Bayes classifier, very popular for the purpose of text classification because of its ability to work with many features. And then we build our prediction based on our X-test data, see the breakdown of predictions, and finally our classification report. So we got an accuracy score of 67, which we were quite happy with, although we noticed that the sort of gains here were not evenly distributed, and in the recall in particular for non-5-star reviews was really low. And so for that reason, we actually decided to try using an XGBoost classifier, another type of classifier that's popular for this purpose, using some popular sort of common arguments for the purpose, fitting that data, making new predictions, just because we wanted to see if it would be more accurate. And we found that it was slightly more accurate at 71. And more importantly, the accuracy was better distributed among 5-star and non-5-star reviews. You can see that the recall here is a bit higher. So we recognize that this accuracy score is not extremely high, but we also recognize that the sample size is relatively low and that the stakes of something like this are lower than, say, a machine learning classifier that's making major medical decisions or financial institutions at a large level or something like that. Although that said, with more time, more data, more use of the API, we would like to actually increase the accuracy of this classifier. And so beyond that, taking that purpose one step further, we wanted to actually understand what features went into making those decisions. Machine learning classifiers are often referred to as black boxes, but there are ways to understand what features were important. And the XGBoost classifier, you can actually use a method called feature importances, which produces a score based on that, which we then represented in a data frame and sorted from top to bottom by what scored the highest. So here's just a list that you can look at of, in order, what features were considered most important for the model. And then we actually decided to represent that as a word cloud, just to get a quick overview visually, where the larger words are the ones that were deemed more important by the model. So another thing we recognize here is that some of these words or tokens might not be especially helpful. For example, very good, amazing. These are words that one might expect would be associated with very positive reviews, and it wouldn't be especially useful business advice to tell someone to make their restaurant very good or to make the food amazing. I think they already know that. But there are some decent insights buried within that, some sort of diamonds in the rough. And so to identify those, we built a function that basically allowed us to put in one of the features and then see what kind of all the examples of the reviews where that word came up. And so trying some of them out, what we found was that, for example, comfort and welcome were really important. And so maybe reviewers in these zip codes were really emphasizing kind of cozy, welcoming atmospheres, which you can imagine potentially in contrast to something that's a little bit flashier and potentially even more expensive. We saw that celebration and words associated with parties were really predictive, and that's useful because a business owner could decide to make their establishment especially welcoming to large parties and to celebrations, recognizing that people who come to celebrate their birthday there might have a lot of people who can each leave reviews, and that if they are delighted by that experience and if the restaurant is especially accommodating of them, they might have really positive associations with that. So that would be a choice that a business owner has to make, to be accommodating to those parties and to be really on the ball when they're there, so that they leave with a positive impression and leave a 5-star review. And lastly, delivery was kind of predictive in both directions. It was really important. And it's something to note for businesses that are going to use a delivery service to make sure that whatever service they use, they're consistently happy with, because it can really swing a review one way or the other. People can either be really happy with how well the food traveled, or they can be furious that it never arrived. And so this is something that might not be the business's fault per se, but they should be really careful when using a delivery service to make it work really, really well. Yeah, so that's pretty much it. There's a lot more words that could be tested here, more data that could be input, and more accuracy to be gained. And that would be our focus going forward as we learn more about different models and are able to cultivate more review data via the Yelp API. So that's it. Thank you very much, and feel free to send us any thoughts or questions.